Yes po.
Okay, let's start with the presentation if you don't mind. Okay, so how can I make? So who wants to start? Who wants to volunteer to present their paper? Any volunteers? Volunteers? None. So let's do it alphabetically. Okay, so let's do it alphabetically. So Mr. Brasino, are you ready to present your paper?
I think, sir.
It's okay. Don't ano, chill. Don't be nervous. So I will make you as a presenter. Okay. You are not the presenter, so you could share your screen. Kindly share your screen and kindly present. So you're muted, so we can't hear you. So and
There. Can you hear me now? All right.
yes, I can hear you now.
Sige. Yep. Okay. So, good evening, everyone. I will be presenting the paper entitled Fuzzy Logic Based Control System Temperature, pH, and Water Salinity on Vaname Shrimp Ponds. A little background. I am part of the Smart Farm research team, so I will be presenting most probably papers that are related to Smart Farm. So, Vaname shrimp species is actually one of the most common uh, shrimp that is being sold in the market today. So here, in order to optimize or to keep up with the demand, we need to optimize the growth condition of the Vaname shrimp. In this paper, they will be optimizing or they will be using the parameters pH, temperature, and salinity for the survival of the Vaname, Vaname shrimp. Excuse me. And they have defined the ideal um, conditions in order to grow the shrimp for the salinity, the pH, and then the temperature. So the problem with this is that in their setup, in their very traditional setup, the houses of the farmers are very far from the shrimp ponds because shrimp ponds need to be near the shore. So it costs a lot of time and money in order to grow and monitor the shrimp ponds. To address this, they will be using a fuzzy logic system in order to monitor and optimize the condition of the shrimp ponds real time. So Their structure is that they will be using um, fuzzy logic. So their inputs will be the pH, temperature, and um, salinity, and then their desired output is for the um, activation of the water pump and then the water spool. So their hardware schema, um, the sensors, the temperature, the pH, and then the salinity is connected to the Arduino Uno, and then additional for the Wemos D1 Mini for the web connectivity, and then for the motors as well. So they will they have used fuzzy logic, so meaning they have um, undergone three steps: fuzzification, and then the inference engine, and then this defuzzification. So for fuzzy logic, I think we are, because I have not taken fuzzy logic yet, but what I know is that they are using linguistic values in order to define the system. So, for example, for the temperature, they have designed this degree of membership, and then they use the ideal temperature for the Vanome shrimp as the normal temperature, and then whatever is lower than that will be the cold temperature, and then whatever is higher than that will be the warm temperature. However, in fuzzy logic, there is no defined um, condition or border for cold, normal, or warm temperature. So they will be using the fuzzy logic in order as a kind of a decision maker. So they have created if then rules as well, and yeah, based from there, the system will generate um, the desired output. Like for example, in the salinity, if the salinity is lower than 22 parts per thousand, and then the pH is um, lower than 8.5, the water pump will turn on, something like that. So in order to test their system, they have used a small prototype in an aquarium, and then they have calibrated the sensors, the temperature, the salinity, and then the pH sensors, and they were able to successfully control the system in the aquarium. However, they did not do it in the actual setting. So um, the advantage of this method is that it is easier to implement for simple systems such as this, because it's parang there's only input and then there's output, and then you let the system decide. So one advantage or disadvantage of this is that it is not that accurate because we are not using mathematical expression, or I mean we do not have defined mathematical quantity for or equations for this kind of system. Um, the paper does not contain the recommendation as well. So, however, if I will be doing this um, paper, I will try to do it in the a real smart farm or in a real farm. That's it, sir.
Ah, good. Good. So, are there any questions from other people? So, there are none. So, thank you for that. So, just to sum up, just to sum up what he said, what he did, what his paper contained, it contains it contains fuzzy logic. So the question is, what is fuzzy logic? We will discuss fuzzy logic later on in this term, but for simplicity, fuzzy logic is fuzzy logic is a decision maker. It's an artificial intelligence method used for decision making. Okay. So that's why in the paper he has the proponents have several sensor values, and then the fuzzy logic would then know what would be the next thing to do, or what would we do given this sensor value. So thank you for that. Okay, thank you for that.
Thank you, sir.
Next one. So who would be the next presenter? Would be the next presenter? The next presenter would be
Sir, ako na lang.
Mr. Kian
Okay.
Tan.
Never mind.
Okay, go, Mr. Kian Tan. The floor is now yours. So
Okay.
kindly share your paper.
Wait lang.
Go lang.
Sir, pwedeng yun, kasi gamit ko yung iPad, pero yun sa desktop nakapasok naman.
Okay.
Pero hindi siya nasa-share.
Okay. You can't share it yet.
Ah,
So,
yung color purple na circle po yun nasa desktop ko. So, baka yan na lang yun.
okay. So, wait. I'll change. Wait. Yan.
Ah.
Is it okay?
Lang.
20%.
Nakikita na po ninyo, sir.
No, not yet. We can't see it yet.
Ah. Ah, hmm. Wait lang.
Go lang.
Wait, sir. I-try natin yun isa naman.
Go
Sorry.
naman. Okay.
Yes.
Excuse me.
Ayan.
Alright. It's found below. Screen sharing is found below.
Wait lang, sir. Okay. Hello, everyone. My paper is about artificial intelligence of things wearable system for cardiac disease detection. Mainly, this paper has several parts containing wearable ECG, user interface, and cloud server. But I will focus more on the AI-based algorithm. Okay.
What?
Narinig pa ninyo yun, sir? Hello?
Choppy.
Hello?
Medyo choppy. Kinda choppy.
Hello, hello?
Hello?
Hello
Hello?
pa?
Yan. Much better.
Okay.
Game pa ulit. So,
Okay. So my paper is about artificial intelligence of things wearable system for cardiac disease. Mainly, this consists of uh, several parts. It has a wearable ECG monitoring device, user interface, and a cloud database, but I would focus more on the AI-based algorithm. So, introduction. Uh, Arrhythmia is a leading cause of heart disorder. So, the study for this paper would is to build a convolutional neural network that would be used to classify and analyze real-time ECG signal. So why convolutional neural network? Because compared to the other neural network, this one is used specifically for image analysis. So what is the difference? In a convolutional neural network, it has convolutional layers. And that convolutional layer has a uh, kernel which contains a filter. And that filter, uh, it is used to extract features or images or patterns like simple lines, circle, which eventually would be connected to recognized shapes. So as we move on, the technique used is so over here, AI-based algorithm. The structure of this algorithm has two segments. Is the processing and convolutional neural network model. So in the data pre-processing is further divided into three steps.
Oh wait, oh wait. I can't understand. Can't
Sorry,
understand. Maybe it's ano eh, it's
Uh, Medyo choppy po.
at Shopee.
yeah, copy.
Wait.
Yan, okay na.
Okay. Uh, Actually,
Okay.
I made
Wag ka na lang
mm,
mag-present na lang or uh just tell us because maybe naglalag, you're lagging because you're presenting something. So what you could do is you just since you already showed the paper to us, so what you could do is
ah,
just tell the
okay.
story behind that paper.
Okay. Actually, gumawa din ako ng Google Doc. So, kung ano na lang yung summary ko dyan, yan na lang sabihin ka. Okay. Which part is the choppy one for you?
After after you said that you're gonna focus on the artificial intelligence part of the study.
Okay. So, I would focus on the artificial intelligence of the study. So, the technique used here is a convolutional neural network. So the structure for this algorithm has two segments, the data pre-processing and eventually the neural network. So the first segment, data pre-processing, it includes three steps: noise removal, baseline removal, and image generation. Uh, so for the noise removal, they made use of a filter, which is the 8-point moving average filter, which main purpose is to get the average of the output signal, then reduce the noise, then enhance the peak value. Second step is the baseline removal. They made use of the polynomial fitting. So its approach is to subtract from the original signal in order to obtain the baseline from the data. Then the third step, which is image generation. So uh, it imitates how the cardiologist reads the ECG signal. So being ECG, because on this paper it's focused on sort of personal use or small ECG, so the computation power is not that strong. So the only thing it would read is the abnormal or normal signal. So going to the next segment, which is the convolutional neural network model. So uh, how is it different from other neural networks? Mainly because the CNN model or the convolutional neural network is mainly used for analysis of visual imagery. Uh, for this purpose, we made use of the one-dimensional neural network instead of two-dimensional or three-dimensional, since we're just gonna read signals in a one dimension. So this convolutional neural network, uh, it's different from other neural network because it has a convolutional layer which has a kernel which serves as a filter in order to extract uh, or read or analyze patterns. So mainly this model has four convolutional layers and three fully connected layers. Then eventually, after the pre-processing data, those images are then brought to this model, the neural network, which is used for training data, validation data. So what are the advantages? Since since the data is most it would be similar to that of a cardiologist as a reference, and it has a simpler identification pattern. For its disadvantage, since it requires pre-processing data or in order for it to analyze, there is a possibility that it won't be able to analyze some other types of arrhythmia. So the recommendation for this study is to have more data, not only from the clinical trials, but also from the arrhythmia database to improve its analysis skills. And that's it.
Good. Thank you for that. So to summarize what he just presented. So the main point that I want to that he wants to share with you is that the technique that he that the technique that the authors of the paper used was convolutional neural network. So convolutional neural network is a type of neural network. It is mainly used for images for image, but in this case, they used it. They tried to trim it down. They tried to trim the convolutional neural network down so that it could be applied on uh what's that, ECG? Am I
Yes,
uh
ECG signals.
on ECG signals? So that's it. So that's it. Thank you for that. So that's good. That's comprehensive. So who would be the next one? So for the next presenters, if you're gonna discuss the technique, you can only discuss you could just state what technique they used. Okay, so because we're running out of time. Okay, example, they used genetic algorithm or they used fuzzy logic. So you just say, "So for this part we used fuzzy logic. For this part we used ganyan." Okay.
โอ้
So who would be the next one?
คนนี้เฮี้ยนเอาไปให้แม่อยู่อันนั้น
So I would nominate
คนนี้เฮี้ยน
I will nominate
เฮี้ยนอยู่เดี๋ยวนี้
Mr. Carlos. Justin Carlos.
Hello. Hello.
บ่มีใครอยู่หั่นบ่
You're
ฟังออกก่อนได้บ่
naka-echo. You have an echo. Hello. Hello. Uh, it's echo. There's a lot of echo. Or
Wait,
am I
sir,
wrong?
I'll try to refigure.
Kindly mute the one of your sources. Hello. The other source works. I don't know
Yes, sir. Yes, sir.
because it's having a feedback, or you just have a feedback.
Hello?
Hello. Yeah, that's better. Hello. Hello. What happened? Oh. Oh, you're not the presenter. What happened? Oh, so he's having technical difficulties.
Hello?
So yeah, that's good. Hello. Hello. Are you ready? Why? He's having some technical difficulties. So, while he's setting up, let's have another presenter first. Is it okay? Okay, so let's have another presenter first. So who would be the next one after Carlos? Sipeng Pet, are you ready to present? Sipeng Pet, you're muted. Sipeng Pet, Mr. Sipeng Pet,
You are now unmuted. You are now muted.
are you
You are
here?
now unmuted. You are now muted. You are now unmuted.
Hello sir
Hello. So you're now the presenter. So are you ready to present your paper?
uh yes sir
Oh, okay. So it's located at the bottom if the share screen is located at the bottom. Excuse me.
yes sir can you see my screen
Not yet. Because I already see your screen.
okay can you see
Yeah.
okay so hello everyone so today I going to report or present discuss about the paper that I have selected so the title of this paper is the selecting of artificial intelligence technology for control of mobile robot. So in this paper, the purpose of methods of the selecting of the optimal artificial intelligence by set of the available technology for control of mobile robot allow to improve the functional characteristics of the robot control system at a one or an individual system by the optimal coverage of the set of tasks and posture shown by the robot control system. So the main problem or main system in this paper in view of the complexity or impossibility of formalizing the control problem. The solution is supposed to be carried out with the involvement of artificial intelligence method. So in this paper, uh, there are two sets that is suggest uh, algorithm for estimation of efficient and selection of artificial intelligence technology for solving tasks of mobile robot control. So there are to set the initial data. So following by this function. So number two is to carry out calculation in the following sequence by following this equation. So in this paper, they use physiologic physics performance. So for this case, I don't understand because I don't have experience about the physiology before. So the resource of the section. So here is the data of physics performance relation of this paper. So for the conclusion in this paper, for the specific control system of a mobile robot sprinkler system or features has been developed mathematics. So there are generic algorithm application of a neural network expert system algorithm based on the fuzzy control. So which is can be used in this mathematical model. So this is sir.
Okay. Okay. Thank you for that. That's good. So in his paper, what he uh is used AI is primarily used in mobile robots. So what AI technique the technique used is fuzzy logic. And then uh in the table one, uh can we see the table yan? Yan. In the table one, that table corresponds to your fuzzy values, the relationship values, which we will discuss later on. So what is that? So maybe now, some of you don't understand what this means, but later on in this course, at the end of later on, we would start we would allot half a meeting just to study fuzzy logic. Okay,
Okay,
we would
sir.
allot half meeting, but it's okay. Fuzzy logic is one of the easiest artificial intelligence technique out there. So thank you for that. Good.
Thank you, sir.
Next, who would be the next one? Let's have Mr. Tolentino. Mr. Tolentino, are you ready? Mr. Tolentino. Excuse me. Are you speaking so we can't hear you? Apparently, we can't hear you. Mm, Hello? Can't hear you. Are you speaking right now or not? You're speaking, so we can't hear you. We'll just configure your mic. Oh, while waiting, Mr. Carlos, can you present already? Are you ready, Mr. Carlos?
You are now muted. You are now unmuted. You are
Oh,
now muted.
he
You are
left.
now unmuted. You are now muted. You are now unmuted. You are now muted.
Mr. Shong, are you
Hello,
ready?
sir. Do you hear me?
Yeah, I can hear you.
Okay. Thank
So
you.
let's you'd be the presenter first before Aldrin.
Okay,
While he's
it's all right.
configuring his mic. Okay.
Yes.
Okay. Kindly, you're now the presenter, so kindly share your paper to the class.
Share Excel screen. Let me share.
So share screen is located at the bottom.
How to share screen? Wait.
Hello, sir. Who's presenting?
Let's just ask Mr. Shong first. Let's wait.
All right, sir.
Okay, Mr. Shong.
Yeah.
We'll just wait. Are you ready? So did you share? We can
Uh,
see your
do you,
screen yet?
do you, do you see my screen?
No, not yet. Not yet. Kindly configure it again.
So,
Can't see it yet.
you see my screen?
Not yet. Not yet.
Yeah. So we go for the firstly, we go to the class, right? The action, right?
What? Again?
Okay. Right, okay, yeah. So right now I got it. Okay. Do you see my screen?
Mm, yes, it's loading already. Good.
Okay.
It's already showing.
Okay, thank you. So hello everyone. So today I will come to present about the smart hydroponics farming with the IoT-based climate and nutrients manipulation system. So for the extract or the significance of the paper or this paper, we would like to show about the temperature or the technology for the hydroponics system. For example, in this paper, we also solve the problem and saw the monitoring in the new technology or the IoT based. So this problem, why we would like to use or solve the problem, because every people they need good quality food or the food or the products that they need the quality and quantity. So this is the biggest problem of us. If we using the good quality, that will be healthy and very helpful for the human. On this paper, so we have to make the lettuce or growing area food. For example, we can grow without soil and we can grow in the urban farming. For example, in here, so they also, for this example, so they can grow in the urban agriculture have been developed in the Barcelona or the Barcelona Kansas City. They decide to grow in the city. So as well as our future, we also would like to grow or make the farm in the building too. And other reason, we also would like to make but the problem and the idea is coming from the 17th centuries that they have to make the idea and present about the Newton solution. The Newton solution is the best idea of us, and we would like to solve the problem. So in the Newton solutions, we also see what's what do we need to make it. These elements is in carbon, hydrogens, nitrogens, and phosphorus, potassium and calcium, magnesium and phosphorus, sulfurs, ions and carbon, zinc, and other mechanical or other idea from the chemical to apply of us projects for this idea. So I also love to use or like to use the idea from design. As this idea, they're also using the Arduino or the Node MCU. That's the tool for connection between the computer or the smartphone to the, the farm. And this is to control the sensor of the farm or the smart farm. So we can control as the flow, the water flow or water level, pH of water, and electric conductivity, humidity matter, the last matter sensor, and each other wise. So we come to the idea of the farm. As we can see here, so when we using the main computer, we can control the LED loop and power or Aerator and nutrient solutions gate and pH manipulator gate and also oxygen gate to supply in the farm. But this one is the the one we need to control. But the problem, if we using the computer or we make this project, we want to spend a lot of the fund and we have to using the good computer. The good thing or the advantage is very easy to control when we make these projects. But disadvantage, we use a lot of fun to make these projects. And as the recommendations of this paper, so they also suggest to using they also suggest to using about the image processing or the camera uh, as the recommendations. So yeah, for the okay. So they also need to make the idea or to plan with the image processing. That's why they need the camera to apply with. So this paper, thank you so much.
Okay, good.
Okay.
So good. So in this case, his research is more of a smart hydroponic farm. So the what my comment here in this is that the method uh of of making a smart hydroponic farm is not in this paper. This is not yet deep artificial intelligence. This is more of a basic one. So yeah, as you can see in the climate manipulation, that's a basic one. But that's okay.
Yeah.
That's good. But that's okay. That's good.
Okay.
So maybe if you want to focus on doing a smart hydroponic farm, So you could improve that paper if you don't have a topic for your paper yet. You could improve that paper, and you could find a better artificial intelligence model rather than just solving for solving for the values of k, the values of each level. So that's good. It's good. So next,
Thank you.
thank you for that. Next, so Mr. Tolentino. Let's have Mr. Tolentino first.
Okay, sir.
Mr. Tolentino first.
Let me know if you see my screen.
It's already loading. So kindly make it quick so that we could start the discussion by 7 or 7:05.
Alright.
Okay?
Okay, sir.
Good.
So the title of my paper is Tree Classification in Complex Forest Point Clouds based on deep learning. So basically, for the introduction, this is basically an AI that classifies trees. So in the he calls it actually letter. So in this letter, um the novel thing that he proposed is a method or framework on how to classify trees. So he said that there tree classification is already something that is getting more popular, and that's why he wanted to tackle it. So he cited various papers with different techniques in classifying trees, but here in his methodology we can see what he did. So basically, the in his methodology he has three steps. First is the individual tree extraction. So it's basically that's basically the data gathering for for the model. And then the next step is he has to pre-process the data. So this is basically the data cleaning. But specifically what he did for pre-processing is noise removal, to like isolate the tree itself, to separate it from the nearby trees or the ground, so that you just get the tree itself. And then for the second step, um, he also aligned the tree to the axis of the coordinate system, because most of the trees that they got from the forest point cloud were out of axis, since it has are trees land on a slope. So he just the second step was just to make it parallel to the horizontal. So for the third step in his methodology, he used voxel. I mean, this is part of the second step, pa pala. He used voxel based rasterization. So this is basically with the 3D point clouds already and pre-processed 3D point clouds. He took they took pictures. The study took pictures, 2D pictures of the 3D point cloud. So it's basically like rotating your figure or model and creating many images. So here is an example of the rasterization that they did. So this is the 3D point cloud, and they made several 2D images out of it. So that's the rasterization. And then for the last step, they used deep learning to be able to classify trees. So in their classification, they used um, data DBN. So this one is a very technical term which I'm not that familiar of, and they say it's also involved with Boltzmann machine. So aside from that, here are like the equations that they used, and then moving on to the experimental setup that they did. So yes, again, here is like a summary of their methodology. They gathered the data and the rasterization, then the model training, then the testing. So in the deep learning, they had those are the two, basically the two phases. They train the model with the data, and then they test the the accuracy of the data by letting the model predict what kind of tree the test data is. Okay. So for the results, for the results, they used they didn't gather the data themselves, so they just used two existing data sets, and then for their first data sets, wherein they used 343 samples, 343 samples for training and 248 tree samples for testing. They garnered an overall accuracy of 93% for the tree classification. So it correctly predicted what tree it is, what tree the test data is for by 93%. And then for the second data set that they used that because it had a comparison. That data set already had an existing experiment wherein it also predicted which tree it identified. So when they used this data set, they were able to get 95% accuracy and 0.9% kappa coefficient. And this was shown in this table. So the method that was originally used from that data set got 85%, and his new four-step or three-step method was 95%, which is a lot better than the method proposed in the previous paper. So in conclusion, the model and artificial intelligence successfully predicted and classified the trees um, and achieved the objectives. So for recommendations, he said that it would be good to consider more effective ways to even improve on the accuracy of like classification, and he also said that possibly this method can be implemented in other kinds of 3D objects. Thank you.
Ah, good. That's nice. So, brief, short summary. He used the paper used what we call deep learning. So there are types of deep learning. So deep learning is a type of neural network which we will discuss later on. So deep learning, and then the particular deep learning tool he used was DBN, which is the deep belief network, which we will discuss later on, naman. So so that's good. So he used artificial intelligence, particularly deep learning, on characterizing trees. Good. So for the last person, so Mr. Carlos, are you ready?
Hello, this is better.
Ah, yeah, that's better. Way better.
Okay. Okay.
Okay, so kindly present your paper. Making your presenter right now.
Okay. So, um, is it presenting already?
No, not yet, not yet.
Okay. How about this one? Is it presenting
Ah, yeah,
already?
it's already loading.
Okay. Sige. Uh, is the PDF on screen already?
Yeah, yeah, yeah.
Okay. So, hi guys, good evening. My paper is about Model Ops, a cloud-based lifecycle management for reliable and trusted AI development. So, this one is more or rather, this one tackles the method on how the AI learns. And in this paper, they discussed a new method for the AI to be able to learn more quickly and more precise in the sense that they are in the sense that the method for learning is less error prone and more efficient. So upon reading the paper, they discussed the challenges when it comes to the AI lifecycle, which are the following: the automation, wherein runtime monitoring can be time consuming and error prone, the quality assurance, the traceability, wherein in usual AI learnings, teams need to answer questions like which data model was this model trained on, and which code or data change made our accuracy deteriorate. There's also risk management involved, since additional tests mean additional risks as it goes on. And the feedback cycle also, wherein the continuous improvement of models require an efficient yun nga, feedback loop. And if the feedback loop isn't good, then it could most certainly just keep on repeating the same mistakes over and over again. So with this, they devised a new method of AI learning, which they call um, model ops. So in model ops, it's actually a combination of AI lifecycle and DevOps pipelines. So to give a brief background regarding DevOps, DevOps is a combination of cloud computing. I actually searched it a while ago. So yun. So DevOps is actually a set of practices that combine software development and IT operations. So the two are combined so that it could become more efficient and take less time to produce while being able to produce the best amount or set of data. So, ayun nga, I'll skip this part. We'll skip to the system design already. So, for their system design, as seen in the figures here, figure 1 shows the model ops platform architecture. So, looking at this, it's kind of uniform, but uh, it's segmented. It's such a way that it looks like a pipeline. Since, as you can see, data like code repos and CI/CD, data pipelines, model train and serve, and other stuff are first and foremostly injected into the model ops platform, and then the model ops platform is categorized into four main parts, which are the execution core, model ops core, data access core, and the data storage core. So from here, what it does is it first executes a certain event, which is then followed by the model ops core, which is to model the actual AI, and then followed by the data access, which will then be eventually stored in the data. So in figure 2, they showed the sample pipelines, wherein the first pipeline is a simple train deploy pipeline. So what happens here is that data is pre-processed, which then um, gives an issue to train the AI model, which will then be evaluated. And during the process of evaluation, it could keep on repeating, it could keep on training until it reaches a certain standard before being deployed. And in the second pipeline, this one is actually a complex pipeline with custom plugins enabled. So as you can see, there is an added bias detection and evaluate, but we can see that there's no connection between the bias detection and the evaluate, since it's a pipeline naman. So what they did here was they placed in custom plugins which could be totally unrelated to one another. And then the third model right here is the transfer learning pipeline with user specific models. So this one is very similar to the first pipeline, which is a simple pipeline, but this one, after evaluation and reaching the particular standard necessary, it then goes to the base model, which will then be transferred to user-specific models. And the user-specific models are also pipelines, as you can see. So there. And then the figure here, figure 3, shows a simple model training pipeline with metadata. So what happens here is that yeah, the basic definitions, if you search it up on what pipelines are, technically it's a series of events or data that are parallel to each other, but they're still related in some way. So in this one, it's split into two, which are the entities and the events and tasks. So for this simple pipeline, um, for the event, the data needs to be changed first. So there should be like an input, a data input or something. And this data will then be stored for to an entity called the training data. Then afterwards, a task will be used to carry out to train the model, which will then lead to another event, which is the updating of the model. And the model will be updated and constantly trained using the training data that was stored previously. And then afterwards, the model will be further refined before it is updated once again. And as the events take place, the model is also being affected in such a way that it is also being trained. So, yun nga, the definition of parallel, as something is going on, another thing is also going on. So, yeah. And the other figures are only samples of what I had mentioned earlier lang. So, yeah, I don't understand much of this since pipelines are relatively new to me. It's something I learned like within this week only. So yeah. And as for the conclusion, they stated that many teams are still struggling to leverage the full potential of AI in their applications. And this is partly due to the investment in skills, tooling, and platforms needed to support AI life cycles while meeting enterprise governance requirements. So there's still limited resources uh, given in order to fully develop a model that is really efficient and uh, produces precise data. And yeah, and basically what they said was their work was used to provide a foundation for the emerging field of AI lifecycle management. So this was more or less parang a stepping stone in developing a life cycle model management for AI that would be quite precise and is able to learn relatively quick as compared to other models. So yeah, that is all. Thank you.
Okay, thank you. For your paper, his paper is more on the software engineering standpoint rather than the AI. But it's related to AI. It's still related to AI, but it's more on the software engineering because in companies in the corporate world, the hard when we are creating AI models, it would take time. It would really take time. Sometimes it takes 2 weeks to create or to test an AI sorry, an AI device. So, so can you hear me naman? Am I being heard?
Yes, sir.
Yes.
Good.
Yes, sir. Clear.
Just so in normally in companies the problem is uh it takes 2 weeks before we it takes 2 weeks before a product with AI sorry, testing a product using artificial intelligence takes 2 weeks minimum takes 2 weeks because you would train the data and so on and so forth. Now what that paper told us is that we could use another we could you could remodel how we test it or how we create that AI by introducing or just by introducing different pipelines by using the model ops. In that case, he said that he used the model ops, which came from the DevOps. So that's more of a software engineering, no, that's more of a software engineering approach. So yeah, we're all done. So thank you for your reports. So now let's have a short break. Is it okay with you? Let's have a short break. So uh, let's just refresh. Let's have a short break. So let's. Is it okay with you if we would start maybe at 7:20? Is it okay with you?
It's fine, sir.
So because syempre, because we had a very long discussion. So and we haven't started with the discussion yet. We only had the reporting. So next meeting, I would discuss first my discussion first before we proceed with the reporting. Okay. So let's resume on 7:20. Let's resume at 7:20. So you could go to the CR or you could eat some light snacks. Well, okay.
Okay, sir.
Yes, sir.
Hello? Hello?
You are now unmuted.
Hello.
Hello, sir.
Ah, you're still here.
You are
Good.
now muted.
So are you ready to learn? Let's go. So start the discussion. So I'm no. I'm gonna share my screen with you. Okay, so I'm gonna share my screen with you. Wait for a while. I'm setting it up. Mm, Hi, can you see my screen? Can you see my screen?
You are now unmuted.
Yes,
You are
sir.
now muted.
Yes.
Good. So for today, so we're gonna start the discussion uh, or for the introduction to artificial intelligence. So I will introduce artificial intelligence to you. I'll introduce what is artificial intelligence. Okay. So let's start. So normally, when we talk about artificial intelligence, what comes to our mind is this. So we could have when it comes to artificial intelligence, normally people associate it with robots that you could interact, or robots that could move or has emotions, or essentially the Terminator. So if you watch classic films, so one of them is the Terminator. It's it's a good movie. What else? So but the question is that really artificial intelligence? Is this robot or is this robot really artificial intelligence? Actually, yes. Actually, yes. But what artificial intelligence, what artificial intelligence really is this. So normally, you could see artificial intelligence in when you play chess games. So have you tried playing chess games? You could try playing online chess with computer. That computer that is powered by artificial intelligence. So the manner or the way how he thinks, it's being programmed through artificial intelligence. Or computer games. Or computer games like this. Or another artificial intelligence example is this. A self-driving car. So what's the difference between these three as compared to the last three? So the artificial intelligence is really defined by its goal. So what do I mean by when it's defined by its goal? So in this case, the goal of artificial intelligence is simply to simulate the human mind and surpass it. Okay, so that's the main goal. The main goal of AI is to simulate the human mind. So I need to create a brain, or I need to create a system that thinks like a human being. And and once I'm done with that, since I have that system, I need to surpass it. So I need to surpass human capabilities. So that's the goal of artificial intelligence. It's for us to create systems that think just like human beings. Am I clear? Am I clear with this, guys?
Yes.
Yes. Yes. Okay. So since I'm clear, so now another another goal of AI is to create system that removes the physical limit of human beings. So what do I mean by this? To create system that remove the physical limit of human beings. So what do I mean by this? So what do I mean by this? So for example, a human being, a human being can think and could act. Can think and act. For example, I'm work. This human being is working in a manufacturing plant. So that human being, he needs to carry this box. For example, he has a box. He needs to carry that box to another point. For example, from point A for point B and for point C. Now, now when the human being is given a box like this, he need to think. He need to think, where will I put this? Do I need to put this to A? Do I need to put this to B? Or do I need to put this to C? Now, that's the way how that's now in that component, that's the thinking component of the human being. So and what's good is that the human being, our brains are very 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 complex, are very very sophisticated. So it's very hard to create a program that could match our brains. Now, but the limitation of human beings is the action. Now, for example, for this box, for example, if it's just 5 kilograms, that person could easily deliver that box to any of this, depending on what type of box this is. But then, what if the problem now would be, what if that box weighs 100 kilograms? That can't be. The person, the an ordinary human being, can't do that. Can't carry that. He cannot carry that. So what we could do is we need to create robotic arms. So manufacturing industry creates uses robotic arms. Okay, so they uses robotic arms. They use robotic arms to transfer containment or cargo from one point to another. But the problem is that robotic arm has no capability to think. It could only act, but it has no capability to think. That's why normally there is an operator operating this robotic arm, to so that the operator would be the one who thinks, and then the robot arm would be the one who would act. Okay, so now the goal is this. The goal is we need, since humans are capable of thinking, what we need to do is we need to have a way to have a better way of acting, just like this robotic arm. So since, for example, since we are human beings, we cannot we cannot force ourselves to lift 100 kilo. We have physical limitations, while machines, virtually it has no physical limitations. Okay, okay, machines or robotic arms like this has no physical limitations. So what we need to do is, instead of instead of improving the acting mechanism of human being, what we could do is we need to put a good thinking mechanism for this robotic arm. Am I understood? Is that clear? Since we cannot since we cannot make the person carry 100 kilograms, whatever we may do. So what we need to do is, instead of doing that, we just make the robot arm think. So instead of making the person act, we just make the robot arm think. Okay? Am I clear? Am I clear with my example? Or
Clear, sir.
oh,
Clear.
there. Good, good. So that's the goal of AI. We need to remove the physical limit or the acting limit of human beings. Okay? Now, where do we apply artificial intelligence? So normally we apply it in computer vision, robotics, communication, programming, gaming, music, technology, and medical science, and many, many, many more. Just like the papers presented a while ago, uh, we have two which is used in smart farming, and else we have some robotics, we have some more on the technology. So these are the applications of AI. So the question is, what are the types of AI? So to summarize the types of AI, I want to show you this picture. This is the summary, or this is the summary of artificial intelligence in a nutshell. So artificial intelligence is a very broad it's a very broad topic. is a very broad subject. It has different fields. So you could use artificial intelligence in perceiving and acting, in machine learning, in automated reasoning, in knowledge representation, in problem solving, at the same time in operations research. Okay? So you have 5 ways to use artificial intelligence. So what are these things? So what do you mean by operations research? What do we mean by perceiving and acting, machine learning, automated reasoning, knowledge representation, problem solving? What do we mean by them? Or what do we mean by that? So let's start with the perceiving and acting. So artificial intelligence is used in perceiving and acting. So perceiving and acting, generally we could divide this, or under this you could see computer vision, natural language processing, and robotics. So have you heard of them? Have you heard of computer vision, natural language processing, or robotics? So I should hope that I should hope that you have heard them even once or twice. Okay. So maybe reading your papers, you should know that they used computer vision, natural language processing, or maybe robotics. So first, the question is, what is computer vision? Anyone who knows what computer vision is? Are you still here? Are you,
Hello.
hello? Good, you're still here. So
Yes.
anyone who knows what computer vision is? Any idea?
Uh, I don't know the yung exact definition,
It's okay.
but I think an example is like in uh what's that, facial recognition.
Good. That's a really good example in computer vision. Uh, your phone have facial recognition. It could detect your face. How does it detect your face? So computer vision simply is understanding what the computer is seeing, or in that case, what your phone is seeing. Your phone acts as the computer. So now, so how does the computer see things? That's the first question. If I have a computer, how can it see? So it could see using a camera. Okay? So normally, if you would equip it with a camera. Okay? Once you equip the computer with a camera, the camera would try to get images of, for example, in this case, images of people. And then that image, he would throw it in the computer, and the computer would perform artificial intelligence techniques. So in this case, for example, in this example, he used artificial intelligence techniques to know the movement of each and everyone who are performing that aerobic routine, okay, who are performing or doing the exercise. So that's one example. Another example is this. So another example of computer vision is that given I am given a picture of this traffic scenario, what I would do is I need to separate each and every object. So, for example, in this case, he can separate this car with the truck in front, with the buildings, with the trees, and the stoplights, and so on. So, is this clear? Is this clear? Clear.
Clear,
Yes,
sir.
clear.
Uh, so, for the others, are there any questions, clarifications, variable interactions? Wala naman, none. So, none. If
None.
there's none, let's move on. Natural language processing. Natural language processing, uh, the basic example of that. Since before we delve into that, computer vision is understanding what the computer is seeing, while natural language processing is understanding what the computer is hearing. Okay, we understand what the computer is hearing. Now, in this case, this is a very simple diagram. Will be a man saying, turn on the LED or LED on, and then the LED turns on. That's a basic example of um, natural language processing. Natural language processing is if you're saying something, that's your language. That's not really your language, but that's your natural language. Language, that's when we say language, that is English, that is French, while natural language is the language coming from a person or coming from a host or coming from an ordinary person, because the difference the difference is that sometimes, for example, the difference between a language and natural language is when we say language processing. um when we say language processing, when I'm talking, when I need to talk straight, meaning perceiving and acting, computer vision, natural language processing, robotics, and then the computer would interpret all the things that I've said. While natural language is interpreting uh, what I said with the manner I say it. For example, so what do I mean by that? For example, I'm saying perceiving and acting, computer vision, natural language processing, robotics. So so the difference is that if I put that to the language processing, if I say perceiving and acting, so when we use language processing, the computer will write perceiving and uh, acting. Okay. While if we are performing natural language processing, he could he could know perceiving and acting. Generally he could generally what do you call that? He could generally separate the habits or the person's mannerisms, or the person's parang the person's like the person's what do you call that? I'm having a mental block. So every time that a person has having a mental block, the natural language processing can read through it. Okay, am I clear? Am I clear here? So
Yes,
right.
clear.
So that's what. So it's commonly used. It's commonly used in Apple, in Siri, in Google Assistants. Okay, they use natural language processing. And the third one is robotics. When I saw robotics is simply a robot simply is an object that could perform tasks over and over again. Okay, a robot is a simple is an object that could perform tasks over and over again. So an example of a robot is a simple calculator. That's a very basic robot because it could do tasks and it could do it and it and the calculator can do it over and over again. Now, if we add AI to it, for example, in this case, we could make this robot think. In this case, what what he's doing is that the he would only get the purple cups, not the green ones. And in this case, this is an example of swarm robotics. This so the swarm robotics, you use a very small robot. That's a very small robot with three pods, and that pods vibrate. And once that pod vibrates, and the robot moves. Okay, so now swarm robotics is that each pod could see the other pods. So what they need to do in this case, since I have a lot of pods, I could in this case they programmed this to mimic a star, shape pattern. So I have a lots of robots and they try to reposition themselves to form a star. Okay? So this is part of natural perceiving and acting. So in this case, perceiving, meaning they know where they are, and acting, if they know where they are and they're not inside the star, they would act so that they could be part of that star. Okay? Any questions? Clarifications? Violent reactions? Am I clear?
Not.
None
You are
po.
now unmuted. You are now
None, sir.
muted. You are now
None.
unmuted.
None.
You
Good.
are now muted. You are
Let's
now
move on.
unmuted. You are now
So
muted.
another application or another type of AI is AI that could solve problems or the problem solving artificial intelligence. So in this case, we have two types, which is the search and the constraint satisfaction. So when we say search, a common example of a search AI is the tic-tac-toe. It's an AI that do the tic-tac-toe game. So for example, so in this case, the goal of, the goal of the green one, the green is the AI. The goal of the AI is to think where to put the pieces, where to put the green pieces so that they could line up, so that they could beat the other player. Okay, so why is it called search? So what? It's called search because once that the AI already used his turn, what he does is that he would make a tree. He would make a tree. So what is this tree? This tree is the list of all decisions that he can do. For example, this node says that uh I could put the circle in the middle. So now I'm on this tree. So maybe let's say this is position 1, this is position 2. Maybe this is position 1, this is position 2. Now, the goal is this. So from the middle, or let's say this is 3, this is 4, 5, 6. So 1, 2, 1, 1, 2, 2, 3, 4, 2, 3, 4, 1, so on. For example, what the AI would do is after putting a piece in the middle, what he needs to do is he needs to find the path that would give him the win. For example, in this case, after after going to 4, after going to the middle, he would he went to 1, and then he went to 2. He went this, then afterwards he went 5 for the win. So he used this 3 to win. Am I clear? Am I clear? So in this case, you're just looking for the path to win. Am I clear here? Or you want me to repeat?
Uh, Clear, sir.
For the others, it's clear.
Clear.
Okay,
Clear,
okay,
sir,
okay.
clear.
Good. So this is the basic one, which is the tic-tac-toe game. The a more complicated one would be the chess game. The chess game, it has millions of moves or millions of combinations. So from those millions of combinations, the goal of the computer is to find the the shortest way or the easiest way to win. Okay, that's it. So that's the search. So another thing, when we say search, we have three algorithms under search. So if you took if you have a subject in undergrad, which is related to AI, you should have studied this. So you should have studied the uniform cost search. So we have three algorithms: uniform cost search, the greedy algorithm, and the A star. It's okay if you haven't tackled this yet. So we would be somewhat discussing this maybe next meeting, but this would just be a short discussion because we would focus more on the contemporary AI because these three is what you call the classical AI. It's classical AI because search problems is a very primitive problem. No one only few programs uses search problems. Yeah. Now moving on. Another problem solving technique is the constraint satisfaction. The constraint satisfaction, what is this? So first is, what is the constraint? The constraint is obstacles. So now, for example, if I have an AI that solves the maze, So what is his constraints? His constraints are the walls, meaning I cannot go to if this is the finish line. For example, this is the finish line and this is the starting point. I cannot go directly to the finish line because the walls are my constraints. Okay? So I need to satisfy that constraint. I need to satisfy the idea that that I must not bump or I must not go through a wall. Okay? So that's it. So that's a constraint satisfaction. Another constraint satisfaction is the game of chess. So for example, because in the game of chess, for example, you have a knight or you have a knight here, that knight could only move in a particular direction. In this case, three moves forward or three moves to the side, and then one move to each to one of each sides. So you have an L-shaped move. So that's one of the constraints. And another constraint is that the bishop could only move could only move diagonally. So you need to satisfy those constraints rather in order to win. So that's constraint satisfaction. That's part of the problem solving in AI. Okay, next. Oh, so I'm done with the problem solving. Any questions? Questions?
None.
Clarifications? None. So I hope this is clear. This is now next is automated reasoning and knowledge representation. So automated reasoning and knowledge representation is almost the same. So what is the difference between automated reasoning and knowledge representation? Automated reasoning is that before we go into knowledge in automated reasoning, first let's discuss what is knowledge representation. Knowledge representation is that if I have let's say if I have an apple, if I have a mango, so now if there are two fruits here, let's say we have three fruits. So what we need to do here is that now if I see three different fruits, so I must represent this. For example, if I see a red circular shaped fruit, therefore this is an apple. Now if I saw a heart shaped fruit, which is let's say it's color yellow, or this is color yellow, then I could represent so therefore that's a mango. While if I see uh long a long crescent shaped what do you call this fruit, this is a banana. Sorry, it's if it's yellow, that's a banana. Now if ever, for example, I saw another fruit which is circular but then yellow, so then based on what I know, I don't know what that fruit is. Okay, so now what we mean by now let's go this the knowledge representation represents each fruit to each characteristic. So apple, it's quite kind of circular and it's red. Mango, it's heart shaped and it's yellow. Banana, it's yellow and it's long. So now if I am given with the circular circular fruit that it's yellow, so it's not part of what I know. So it's not part of my knowledge. So in this case, I need to reason out. I need to guess what it is, and I need to give a reason why. So in this case, if I have yellow shaped fruit that is circular, so my guess maybe 70%. I'm 70% sure that it's a mango, and I'm 30% sure that it's an apple. Now, since I have a higher possibility of getting the right answer when I pick mango. So therefore, for me, this yellow shaped fruit here is a mango. So this is automated reasoning. So it's used on games. It's used on games. So what the what we do is that so in a certain environment, in this example, in a certain environment, the AI, uh, the AI thinks. You're thinking. So in this case, this is not an AI, but let's assume that this is an AI. So an AI thinks, what is the best move? So what should I hide? Should I go to this containers? Should I go to that site, or should I attack them, or should I be defensive? So so every move that AI chooses, he must have an automated reason for that. Is this clear? Is this clear? Any questions with this? So
Oh, clear, sir.
So to sum up this slide, automated reasoning, knowledge representation is just representing what I know or what is being taught to me, while automated reasoning is reasoning out of those knowledge which has been taught to me. So a, a good example to perform knowledge representation is and automated reasoning is through the use of fuzzy logic, which most of you have discussed in their papers. Okay. There are two of you who discussed fuzzy logic, which we would be discussing a short. We would be discussing later on, but we would just be having a glance on it. Next, the third type of artificial intelligence is machine learning. Machine learning. This is the new. This is the if the problem solving. If I said the plus problem solving, if these is classical, if these are classical techniques, or problem solving is classical, machine learning is the modern AI. The modern AI. So problem solving is a classical AI. Machine learning is a modern AI. So normally, uh, these days when we talk about AI, we are actually talking about machine learning. So so we have three types of machine learning: supervised, unsupervised, and reinforcement. So when we say supervised learning, supervised machine learning, or in short, supervised learning. I deleted the picture. So supervised learning, for example, I have a picture of a guitar. I have a picture of a guitar. I have a picture of a drum set, and I have a picture of, let's say, a microphone. And then, so my supervised machine learning is that if I want to characterize, if I want to know what instrument am I seeing, I need to have 1 million images of different guitars. 1 million image of different guitars, images, or 1 million images of drum sets, or of different drum sets, and 1 million images of microphones. Million different images. Now, and then, so if I have an instrument here, for example, I have a very uniquely shaped guitar. I have a unique shaped guitar. So what I would do, what the AI would do is that it would train itself. If I see this shape, if I see this is a guitar. If I see this is a drum set. If I see this is a microphone. And then I have 1 million images of this, so that I'm sure that I'm really sure I have 1 million images of it, so that I'm really sure that I could know whether it's a guitar at different angles. Now, if I'm given now with the guitar with a weirdly shaped guitar, since I'm trained, I have already seen 1 million images of guitars. Therefore, I know for a fact that this image is a guitar. Am I clear? Is that clear with you? So in this case, in in machine learning, you are training your program, you are training your computer by giving it knowledge. In this case, you're giving it 1 million images of guitar so that the next time he sees a new guitar, he knows that it's a guitar. Is that clear? Oh no. Okay. Is that clear?
Uh, Clear, sir.
Okay. So,
Clear.
nawala. Okay. Okay. Move on. Next is machine learning, unsupervised. Uh, a while ago, a while ago, the good thing is supervised learning is that we already trained our AI. We already trained our AI with different or with numerous number of images. We have already trained them with so many images. Now, what if you don't have any image to train your AI? That's what we call unsupervised learning. In this case, you would just, for example, in this case, there's a video of a race car driver. So what the AI would do is that unsupervised learning, the difference is that in unsupervised learning, you don't have any training data. You don't train the data. You would just let the AI learn by itself. Okay, in this case, what would the AI do is that he would try to get what looks the same. In this case, the race car. In this case, the green boxes looks the same or has the same color, or it looks like the green boxes are grouped together. So therefore, that's one group. And then this ball and there is a red group that has a different movement as compared to the green ones. So this is another group. And then there are parts which is unknown, which is in the blue group. So in unsupervised learning, we would try to group images or group different objects together, and then the the computer would try to learn from it. In this case, I have three groups. This is group A, this is group B, and this is group C. Now, afterwards, if so that's the if that if this is the first time you run the program, you would group it like that. If you have another image, if you have another video, when you have a race car, you have a race car, how to draw a race car, I don't know. You have a race car, and then you have another image or another video, race car, and it's inside view position. What Since he already learned that this is one group already, what would the AI would do is that he would group this already because he already knows this group. He would group this. He would name this as group A. He would name this as group B, and he would name this. He would not name that, and he would name anything outside of that as group C. Am I clear? So to cut things short, the difference between supervised and unsupervised learning is that just let the AI learn by itself. Unlike in this, you would train the AI with sets with numerous number of images. Okay? Okay? Am I clear with that?
Yes, sir.
Clear, sir.
Clear.
Good. Now, the third one is the reinforcement learning. The reinforcement learning, it's the same type of learning as compared to the living organisms or living things. Particularly, how you train a child or how you train a dog. So, in this case, um, in this case, um, for example, you are training this dog. Let's say this is your AI. You are training your AI. So that AI would perform actions. Okay? And then your environment, it should give your rewards. Or it could give some punishment, or you could give some observations, or you could give some after if you don't want to give some observations, yes, yeah, observations, yan lang pala. That's it. So you could give actions, give your rewards or punishment, or give observations. So what's an example for this? An example for this is, have you tried playing video games? Have you tried playing video games against bots or against AI? Have you? Or,
Yes.
oh, yes, the others, have you tried playing video games?
Yes.
Yes, yes, yes. Good. So I'm just checking if you're still here. Okay. So, so for the people, for those of you who play games, so what normally, for example, this is player two. This is your computer, or sorry, this is your computer, and this is you, player one. So, at the start, so as a programmer, if I'm a programmer, if I would program this AI, what I would do is is I would is that I would give certain rewards. There is a rewards, there are punishments, there are observations. So what do you mean by reward? For example, since this player one is a player controlled character, now if he tries to attack this CPU or the AI, and then the AI would perform different moves. So he would try to beat player one. Oh, so he would try to beat player one, but then if this is your first time running the AI code, if this is your first time running the AI code, the AI won't do anything. It's the first time, the AI won't do anything. So that is observation. The AI is observing what the environment is doing or what player one is doing. Okay. Next, then then afterwards, then that's the first time you run the program. The second time you run the program, the second time you run this program, he already knows that if he does not move, sorry, if if he does not, in this case, in number one, if it's your first time to run the program, he would lose. So that's a punishment. So therefore, in the next iteration, since he knows that he must move in order to win, therefore, and in the second iteration or in the second run of the program, he must move. Maybe he must dodge left or right. So while dodging, after the game, he still loses. So he would still incur punishments. So now, so that's and his observation now would be, I need to, maybe I need to fight. I need to punch him. Now, on the third iteration, he now moves while punching the enemy. So now what happens is that I had that AI did some damage to the enemy. So therefore, that's some sort of rewards. Okay? But then the AI still loses. So now on the fourth iteration, so I know, so the AI knows that I need to fight. So then I need to have another plan. The last plan didn't work. So am I clear with that? So in this case, so normally AI in computer games have been trained or have been fighting enemy players for around 1 million games or around 1,000 games. Normally it's around 3 weeks. A while ago I said that normal AI products, there are um I said a while ago in the report of Carlos that what do you call that, normally when you have an AI product it takes 2 weeks. Do you still remember that?
Y- Yes.
Oh, you still remember? So last a while ago I said that there is a there is a time of testing which is 2 weeks, and that 2 weeks, imagine it, your product is a game. So that in that 2 weeks, that AI character fights another player for 2 weeks to train itself to become better. That's also a reason why when you play computer games, the same strategy, if you have an enemy computer and it's maybe if it's in hard mode, the same strategy won't won't be effective. Won't always be effective. It would be only effective on the first round, but then at the next rounds it won't be effective because it already learned from what you did. Okay, okay,
You are
that
now
clear.
unmuted. You are now muted. You are
Clear,
Let's
now
sir.
move to
unmuted.
Yes, sir.
Yes, sir.
reinforcement
Clear.
learning. Good.
You are now
So that
muted.
is
You are
what we
now
call
unmuted.
reinforcement
You are now
learning.
muted.
You're giving rewards or punishment. You're giving some observations to your AI. Okay. This is the last part of of AI. Uh, and this is the most important when it comes to manufacturing, since you're manufacturing engineering students. So this is the most important operations research. So normally it's done in in manufacturing plants or simply in supply chains. So operations research is that a very basic example is that, for example, if I have a paper box, if I have a paper that I want to turn into a box, okay, if I have a paper that I want to turn into a box, how do I do it? So how do I make this carton a box? So what we need to do is you could fold one flap, then afterwards you fold another flap, and then afterwards you fold the other flap. This is more of a this fold another flap, and finally you fold the last flap. Okay, but then the problem with that is that it takes one, two, three. It takes four steps for that box to become from that paper or to that cardboard to become a flap to become a box. So operations research is we need to optimize this process. So how to optimize that process? We need to optimize that process. First is instead of flapping one flap, we could do two two flaps at a time. So on the first step, we would we would do this and this simultaneously, this and then the next step would be this. So it would just take us two steps. Can you visualize this? So instead of having four steps, you could only you could only close this box for two steps. So this is a basic operations research problem. Is this clear? Or do you want me to repeat this?
Clear, sir.
Clear? Good. Wait. Something. And okay. Clear. So what else? Ano pa ba? What else? Did I miss something? So another operations research problem is that, for example, you have been, for example, you have been a consultant of McDonald's. So if you're a consultant of McDonald's, what you need to do is you need to improve their sales. So how would you improve their sales? You could improve their sales by getting the data from from their stores. For example, there are 49 orders of fries, there are 25 orders of burger, and there are 35 orders there are two orders of filet of fish. So you have three menus. So you have fries, burgers, and fish. And normally that McDonald's chain stacks 40 boxes of fries. It stacks 40 boxes of burgers and stocks uh 40 boxes of filet of fish. So what you need to do is you need to suggest. So you need to use AI in order for you to find what is the optimal number of boxes or the optimal number of boxes that McDonald's should order, or that McDonald's branch should order. So instead of you giving ordering 40 boxes, maybe because of that, maybe you need to have 50 boxes. So in this case, your burger, you would bump them down to 35, while a fillet of fish you can bump them to 10, because the demand is quite low for the fillet, while the demand for fries is quite high. Clear? So you should use AI to give a good forecast. Is this clear?
Um,
Maliwanag.
Clear, sir.
Clear.
Questions, clarifications, violent reactions? None? So, okay. Since it's clear, let's move on. Since let's move on. This is the last part. So I'm just gonna give you some story about AI. So this this man is he's Gary Kasparov. Gary Kasparov is one of the legends of chess, one of the greatest chess players who ever played the game. But then, in 19 something, I forgot the exact year. There is an AI. There was a computer program that was built by IBM. Uh, they had an exhibition match between Kasparov and that AI. That AI was named Deep Blue. Okay? Deep Blue is a computer program made by IBM. So Kasparov and Deep Blue went to a match, and then in the first try, uh, Kasparov won against that AI. Kasparov won against that AI because then afterwards, uh, the AI was retrained by IBM, and after a year later, they had the rematch, and then Gary Kasparov and then the Deep Blue AI defeated Gary Kasparov single-handedly. So what do we mean by what do I mean when I told you this story? That means that little by little, the AI is getting better than human beings. So in this case, since since we want to move forward, we could be programmers to program who could program AI. We could be the next generation of AI programmers, or the next generation. In your case, you could be the next generation of AI programmers in the manufacturing industry. So you could maybe create the deep blue of manufacturing. Okay? Okay? Is that clear?
Yes, sir.
Yes,
Clear.
clear.
Good. Good. So that's a short story. So another story. Uh, eh, so this is from a game. Um, there's a startup created by Elon Musk, or so an AI by an AI company by Elon Musk, which is called OpenAI. OpenAI is one of the top researchers in AI. They then so OpenAI. So what they need? So 2 years ago, or 3 years ago rather, or almost 3 years ago. This is taken August 11. So almost 3 years ago, um, the OpenAI created a bot, or created an AI program that could defeat pro players, professional. In this case, this is Dota, professional Dota players. So 3 years ago, but the problem is they could only just beat it, uh, given one by one versus one. So in this case, on August 11, this is a one versus one matchup. So okay, and then a few years later, only a few years later, so 1.5 year later, in April 15, 2019, uh, the rem- uh, the reigning champion, which is OG, defeated OpenAI defeated the champions. So in this case, in a matter of 2 years, the AI could beat professional players on a 5 versus 5 battle. So what do you mean? What do I mean by what do I mean by this? And I why did I tell you this story? I told you this story because wala lang, I really love computer games. Uh okay. Ano pa ba? No. I told you this story because this shows that on a span of a few years, on a span of a few years, you could already beat the greatest in the world. So you could already surpass human way of thinking on a certain field. So you could already surpass humans. In this case, they defeated the international champions. So they have defeated arguably the best in the world. So that means maybe AI, artificial intelligence, could really be, in a few years, maybe artificial intelligence could really, what do you call this? Could really be the people, or could really replace human beings. So yeah, that's it. So actually, that's it. That's it for my presentation. Are there any questions, clarifications? Are there any violent reactions? I I turned off my PowerPoint again. No,
None,
still
sir.
None,
clarification,
sir. None, sir.
violent reactions. Is that my last slide? Yes, that was my last slide. So if you don't have any more questions, clarifications, or violent reactions, I created what did I create? I created where's the big where's the canvas? So I created where's that? So the I already created a submission box. I already created a submission box to set to for you to send your MATLAB code so that I would see your codes this week. So I could check whether you have really you really done it. You've really done it, or you did your research. Then next meeting we would start our first hands-on. We will have hands-on experience on MATLAB on how to use AI on MATLAB. So okay, am I clear?
Clear, sir.
Clear.
Yes,
So
sir.
good. So
Yes,
that's
sir.
that's it for today. So if you don't have any more questions, any more clarifications, or there are no more violent reactions, you're now free to go. Okay.
Sir.
Okay.
None.
Thank you,
Thank you,
sir.
sir.
Okay,
Sir.
no problem.
Sir, I have a concern regarding the
Go.
MATLAB exercise.
Yes, good.
Sir,
Ask.
regarding the 3.2, the item 3.2 sa exercise. Because
3.2. Let
it's
me check.
sir,
Yes. Okay. Regarding the 3.2 and the exercise, what?
because it's asking for an input from variable s, but when I looked at the previous item, it didn't have any variable s that was labeled.
Wait, let me check again. Just give me a few
Okay,
seconds.
sir.
In 3.2? In 3.2?
Wait, sir, I'll check my canvases, the file as well, so that
Yeah, I think it's in 3.2.
Again, so wait. Um, I'm checking, huh? Just give me a few seconds.
sir, yes, 3.2 po. Because it said that to test your subfunction, I test your subfunction by loading the file my data1. This file
Ah,
contains the string array stored in variable
okay.
s.
Okay, so okay. I haven't uploaded the my data file one. I think. Wait, I'm gonna get back to you
Okay,
because
sir.
because when they gave this to me, apparently they must have gave me the my data one file. Apparently they haven't, so I'm gonna check again. I'm gonna ask them again. So I'm gonna get back to you. Okay?
Okay, sir.
I'm gonna give. Thank you for that question. Good, good. Other people, other concerns. Meron pa ba? Any more concerns? If you don't have any more concerns, you're free to go.
Okay, sir. Thank you,
Uh,
sir.
Thank you,
Oh,
sir.
Sir Ren, may
go. Tanong lang. Question.
meron bang parang PDF ng tutorial for MATLAB?
PDF for tutorial for MATLAB, I will supply you with, sige, I would, so for the people who are not that familiar with MATLAB yet, I would upload on the announcement where you can learn MATLAB, okay?
Very limited yun sa YouTube
Okay.
and search.
Yeah, I would give yung crash course. So,
Yes.
hindi. But don't worry. Normally, when I'm while I'm discussing, I would I would tell you why I use this code, why I use this line. So, pero I would be uploading, yeah, okay. I would be uploading a short crash course, maybe. Okay?
Okay, thank you, sir.
Okay. Well, other one.
You are
Other
now
one.
unmuted. You are now
People,
muted. You
other
are now
people,
unmuted.
there are any more questions?
So for next
None.
meeting, do we need to report the paper again or not?
Next meeting, you need to have another paper again. Okay, for those people who haven't uploaded the title of their
You are now
paper in the
muted. You are now
discussion board,
unmuted. You are now
please do
muted. You
so.
are now
Okay?
unmuted. You are now
Please
unmuted.
type. Okay, so that on the next meeting there won't be any. Okay, there won't be any duplicates. So next meeting, please prepare one paper. But on the next meeting, we would do the reporting at the end. Okay, rather than doing it at the first, because a while ago, it took most of our time. Okay.
Okay, sir. Thank you.
Okay.
You are now muted. You are now unmuted. You are now muted.
Questions?
You are now
Questions?
unmuted. You are
Questions?
now muted.
So I guess there are no more questions. So since you have no more questions, okay. So goodbye. Thank you for
Okay.
listening.
Thank you, sir. Bye.
Thank you. Bye bye.
Thank you, sir.
You are now unmuted. You are now muted. You are now unmuted. You are now muted. You are now unmuted.
Thank you, sir.